Task number 5, remote code execution, is part of the upload vulnerabilities module, which is part of the complete beginner path on TryHackMe. It's all well and good overwriting files that exist on the server. That's a nuisance to the person maintaining the site and may lead to some vulnerabilities, but let's go further. Let's go for remote code execution. Remote code execution, as the name suggests, would allow us to execute code arbitrarily on the web server. While this is likely to be as a low privilege user, such as /data on Linux servers, it's still an extremely serious vulnerability. Remote code execution via an upload vulnerability in a web application tends to be exploited by uploading a program written in the same language as the backend of the website, or another language which the server understands and will execute. Traditionally, this would be PHP. However, in more recent times, or other backend languages have become more common, like Python, Django, and JavaScript in the form of Node.js being prime examples. It's worth noting that in a routed application, that is an application where the routes are defined programmatically rather than being mapped to the file system, this method of attack becomes a lot more complicated and a lot less likely to occur. Most modern web frameworks are routed programmatically. There are two basic ways to achieve remote code execution on a web server when exploiting a file upload vulnerability: web shells and reverse bind shells. Realistically, a fully featured reverse bind shell is the ideal goal for an attacker. However, a web shell may be the only option available. For example, if the file length limit has been imposed on uploads, or if the firewall rules prevent any network-based shells. We'll take a look at each of these in turn. As a general methodology, we would be looking to upload a shell of one kind or another, then activating it either by navigating directly to the file if the server allows it. Non-routed applications with inadequate restrictions, or by otherwise forcing the web app to run the script for us necessarily in routed applications. Web shells. Let's assume that we found a web page with an upload form. And here we have just a web page with an uploading form. Where do we go from here? Well, let's start with the GoBuster scan. From the GoBuster scan, we see that we have the uploads directory and assets. And we have 403 for server status. But uploads is what we are interested in. Looks like we've got two directories here, uploads and assets. Of course, it seems likely that any file we upload will be placed in the uploads directory. We'll try uploading a legitimate image first. Here I choose out the QDoc photo from the previous task. Okay, so from the application, uploading form, boom, we select and upload the dog photo. File uploaded successfully. Now, if we go to the uploads directory, we should see that the Spanish, right, the photo, okay? And this is exactly what we see. And we activate it by going, actually, we can see here, going to the directory and the picture. Okay, we can upload the images. Let's try a web shell now. As it is, we know that this web server is running with a PHP backend, so we'll skip straight to the creating and uploading the shell. In real life, we may need to do a little more enumeration. However, PHP is a good place to start regardless. A simple web shell works by taking a parameter and executing it in a system command. In PHP, the syntax for this would be this. This code takes a get parameter and executes it in a system command. It then echoes the output out to the screen. Let's try uploading it to the site, then using it to show our current user and the contents of the current directory. Here we can see in the, we created a file, webshell.php, that contains this code. And after that, we just query it with cmd equals whatever command we want. And it will display over here. Here we have two commands, whoami and list. ID also, yes. ID first, whoami and list. Right, ID, whoami and list. Success. We could now use this shell to read files from the system or upgrade from here to a reverse shell. Now that we have a remote code execution, the options are limitless. Note that when using web shells, it's usually easier to view the output by looking at the source code of the page. This dramatically improves the formatting of the output. And a reverse shell example, This process for uploading a reverse shell is also almost identical to that of uploading a web shell, so this section will be shorter. We'll be using the ubiquitous Pentest Monkey reverse shell, which comes by default on Kali Linux, but can be also downloaded here. Basically, you go to the Pentest Monkey and you just access the code for a reverse shell. But we will copy it from our machine. You will need to edit line 49 of the shell. It will currently say, yes, so the IP, you have to place our IP and the port. Right, tune 0. Okay, so basically just explains to find your IP from tune 0 if you type ifconfig, and then change it over here in the reverse PHP code. You can ignore the following line, which is all okay. With the shell edited, the next thing we need to do is start a netcat listener to receive the connection. Here is the command for the netcat listener, and we open that. Now let's upload the shell, then activate it by navigating to here. Right, so we go again in the uploads vulnerability after we uploaded the shell.php and we activate it. After we do this, we should have the reverse shell open, and you can see in this snapshot that we have. Once again, we have obtained remote code execution on this web server. From here, we would want to stabilize our shell and escalate our privileges, but those are tasks for another time. For now, it's time you try this for yourself. Navigate to shells. Alright, so answer the questions below. Run a GoBuster scan on the website using the syntax from the screenshot above. What directory looks like it might be used for uploads? Let me try. Nota bene, this is a good habit to get into and will serve you well in the upcoming tasks. Let's just place uploads to see. Alright, uploads is not downloads. Okay, shell. Okay, right and quit. Clear. Oh, what an image. What an image we have. All right, so we need to use GoBuster. GoBuster-u HTTP. Actually, I have copied. Wireless will be from user share wireless rocku.txt. Oh god damn it. Ctrl-Shift-T, we go inside, we say gun zip, we go inside user share wireless and then rocku.txt. Permissions denied, no worries. Sudo yes. Okay, all good. Here we say clear. Here we just say this. And I think we're good. Let me see if the command they used for GoBuster is alright. W. Yeah, but they went for the directory list 2.3 from the dirbus. Okay, let's go and actually choose that. So share wireless GoBuster go actually is dirbuster and then directory 2.3 medium. Okay, let me see. This one. Okay, let's kick this off. So it's resources. We also have assets, but it's resources. We go over here, resources. This is the answer to the question. Now, if we go over here and go inside this one, we should see that directory indexing is on. Jesus. All right, now what we see. Get either web shell or reverse shell on the machine. What's the flag in the var? Okay, so the simplest one is here. Simple.php. We place insert. And inside system, we paste this. Now, let's delete this entire thing. I guess we good now. We go back here. We delete this and we re-upload the file. Simple PHP upload. Upload successful right here to the bottom right corner. And then we say again, resources, simple, let's see now. There you go. But actually we have to cat, command will be cat. We are inside, I think let's see where we are. Print working directory. Inside resources. Cat from var html flag. But actually, let's list inside HTML. Should we go to assets? Let's see the question maybe we have. Oh, actually it's inside var and So it's one upper level. Okay, and we say, let's just list to see what we have in here. Yeah, as expected, a flag txt. Copy this. Oh, right. We have it over here. So this is a simple example of a web shell.